Hello viewers, welcome to Max Academy. Hope that you are well by the grace of Almighty. Here, today I want to discuss about a solution technique and the necessary condition of an exact differential equation. When a differential equation will be exact, we have to know if we want to solve this type of differential equation. Here,
press the bell icon on the YouTube app and never miss another update.
if the differential equation is like that, m dx plus n dy is equals to 0. This is a differential equation because of there is a differential coefficient. Here dx dy are the differential coefficients. So this is differential equation, no problem. But what type of differential equation is this? When it will be exact, we have to know. So I am going when it will be exact differential equation. If here we can separate m, and if we differentiate this m with respect to y partially and n with x partially, and the result will be same. I want to mean del y of m is equals to del x of n. Then we can say this differential equation is exact differential equation. And if this differential equation is exact, then we have to solve it very quickly and very easily by imposing a rules. Here I am just writing. Here two terms is present, m dx and n dy. This term I have to integrate, m dx I have to integrate considering y as constant, plus this term have to integrate by selecting which term is x free. That is, if there is any term which involve x, we have to leave this term, and only the term which is included y, we have to include this term to integrate here. So here x free terms, then the result, that is the solution of the given differential equation, will come out. Now I want to discuss if del y of m not is equals to del x of n. It will not then the exact differential equation. Then how we solve this type of differential equation? Now come to the point. If it is not equal, but mx plus ny not is equals to 0, then our integrating factor will be 1 divided by mx plus ny. We have to multiply 1 divided by mx plus ny by this equation and then integrate. After integrating, we will get our desired solution. Now come, if this is not equal and mx minus ny not is equals to 0, then our integrating factor if is equals to 1 divided by mx minus ny. We have to just multiply it by this term to this equation and integrate. We will get the result very easily. And now the point, if this is equal to 0 and mx plus ny is equals to 0, if these two terms is equals to 0, then how we can get the solutions? Here there is another procedure. If del y of m not is equals to del x of n, and 1 divided by m 1 divided by n, and del y minus del n. This term is equals to only the function of x. Then our integrating factor will be, that is if will be e to the power f of x dx. After finding this integrating factor, we have to just multiply these equations and integrate. We will get our desired solutions. And suppose that this is not only the function of x, then how we will get the solution? Yes, we can get. How? Here the technique is. Suppose that 1 divided by m del n del x of n minus del y of m. This is only the function of y. Then our integrating factor will be if is equals to e to the power f of y dy. After finding this integrating factor, we have to just multiply this integrating factor to this equation and integrate. Then we will get our desired solution very easily and very quickly. If this video is helpful to you, please like my video, subscribe my channel and share to your friends. Thank you very much.
Press the bell icon on the YouTube app and never miss another update.